Alright, welcome back guys. This is the fourth video on our exponents. And we've got a little couple extra rules and laws if you'll remember from that poster we had in the room, and that's been linked into the weekly overview. We also have an addition to our product of a power and a quotient of a power, and power of a product. We have the 0 and the 1 rule. So we're going to cover that here in a little bit too. So here we are with our CLO. Understand when two numerical expressions involving exponents are equivalent, which I think you guys are doing very well. Applying the properties of exponents when multiplying or dividing terms with the same base. Again, all of these apply when it's the same base. It's x to the third times x to the second, or 2 to the fourth being raised to the third power, again in power to power. The base has to be the same. Remember, we have the base, which is that, and then the exponent, which is up here. So it's x times x. You guys are doing very well on that. And know and apply the properties to do this stuff, okay? So let's move on here. Here is the laws of the exponents. Product of a power, quotient of a power. Remember, this one we're covering this today and this, okay? This one is distribution, power of power. Power product is, this is distribution. This one we're just multiplying our exponents together. And this one is when we're dividing, okay? We have negative, which we'll touch on today too, which we won't do too much of. An identity, which is when it's the first, something is raised to the first power. It's just itself, because x times, well, there's nothing to multiply it to. And then when we have 0, it's 1, okay? So let's take a look here. Product of a power. So take note here, very important. Our base is the same, okay? Our base is the same. So how many times are we going to be multiplying x to itself? Well, this one, let's take a look at this. X to the third is x times x times x. Now let's take a look at this one. This is x to the fourth. Well, we're just going to multiply that. X, I shouldn't have used the x there, times x times x times x. How many x's do we have here? We have 1, 2, 3, 4, 5, 6, 7. Well, what happens when we take this 3, we add it to the 4, we get 7. So the power of a product of a power, is just x to the 7th. We add them. It's the same as x. What's our exponent? 3 plus 4. Okay? Product of a power, again, our base, what is it? It's 2 here. Let's equal this out. So our base stays the same. Our exponent is 5 plus 2. Remember, these expressions are being multiplied to each other. So we just add our exponents and get 2 to the 7th. Remember, the base must be the same, okay? Product of a power, we're just adding it. Okay, quotient of a power. Quotient is division, okay? It's being divided. So we have, let's take a look at this. X to the 5th power is being divided by x to the 3rd. We have it here, which is kind of the way we're going to see it mostly when we're working with the exponents here, but that's just the same as this. Remember, this line right here means divide, okay? X to the 5th divided by x to the 3rd. Again, our base is the same. And just think, if we were doing the multiplication, the product, now the quotient, let's just do the opposite. Becomes x to the 5th minus the 3rd, which gives us x to the 2nd power. We're just subtracting the exponents there. Okay? So let's take a look at this example. 9 to the 6th divided by 9 to the 3rd. Our base is the same. Same base, same base. Yep. So let's take this 9, bam, our base. 6 minus 3 equals 9 to the third. Pretty quick and easy. Okay. Like I said earlier, we're going to do the 0 exponent rule. So we have 0 here is the exponent. Anytime 0 is the exponent, it's just going to be 1. We could have 789 to the 0, bam, 1. Okay? Just it's one of those, I'm trying to think if I've seen an example other than working with you guys where I've used that. I'm sure if I look really hard through all my stuff, I might find one, but it's not very common. Okay? We could have this number here, 18,764 raised to the 0 power. It's 1. Okay? If the exponent is 0, it's 1. Now, when it's raised to 0, it's 1. Let's take this next step here. 1 exponent rule. When 1 is our exponent, it's going to be itself. So let's look at here. N to the first is just n. 5 to the first is 5. We could do something that's, say, 3,071 raised to the first. That's just 3,071. Okay? Because it's being multiplied by 1 time while it's itself. That's all I can think about it. There's no other, the exponent is just saying there's just the 1 time we have our number. So it's itself. It's all done. Okay? So 0, and when it's 1, it's itself. Okay? And here's one we touched on a little bit. We didn't see too much. This is really just a way sometimes to write an expression 2 different ways. It's the same thing, but written 2 different ways. So here's our exponent, or our example. B to the negative, it's negative 3. Okay, now I'm sure you guys are like thinking back real quick, like I do, to our scientific notation. And when we had a negative, I think, oh man, it's going to be really small because we're going this way. Okay. That's just what pops into my head when I see a negative exponent. Like, oh, it's going to be really small. It's a decimal or a fraction. And another way to do this is 1 over b to the third. Everything stays the same except, well, it's clearly in a fraction here. Okay? Here. So let's make an example here. If we have 3, let me find a different color here. One that it's easier to see. We have 3, and let's raise that to the negative second. All right. That's going to be 1 over 3 to the second. And that's the same as, we bring this over here, 1/9. Pretty small, okay? 3 to the second is 9. It's way bigger, okay? 1 over 9 in a decimal form is 0.111111 forever. Forever. Okay? Very small. Well, just over a tenth. Bigger wise. Okay? So remember, when we see a negative exponent, think, oh, it's going to be a fraction or a decimal. Oh, let me go back. Okay, practice. On the weekly overview for Thursday, there is a link to Desmos, and here is the class code. We're not going to do the Edpuzzle questions for this video. You guys are going to go there, and it's going to be a mix of all 4 of the major laws and exponents we have covered this week, okay? Take your time, have some fun with it. Office hours, Wednesdays at 10:30 and Fridays at 2:30. Show up, we can go over all of this, okay? Come with questions, pencil and paper, all right? Have a good week, guys.